Have you ever stopped to wonder how we actually teach a computer to see? I mean, really see, like we do. It's the incredible science behind so much of our modern world, from self-driving cars to the amazing apps right on our phones.
Just think about it for a second. To a computer, a chaotic, busy street is, well, it's just a blizzard of raw data. So how in the world does it manage to pick out a stop sign or a person crossing the road? That's the mystery we're going to unravel today. Okay, let's get right into it. We're going to go on a journey to build a computer's sense of vision completely from scratch. And we're starting with the most fundamental question of all. How does a machine even begin to perceive an image? Right, so here is the absolute key to understanding all of this. Computers don't see pictures. They don't see faces or cars or your cat. They see data. For a computer to see anything at all, the world has to be translated into the only language it truly understands, the language of numbers. And that whole translation process, it kicks off the very instant that light enters a camera. This first step is all about capturing the physical world around us and converting it into a nice, neat grid of digital information. What's really fascinating is just how much a digital camera works like our own eyes. I mean, it's a great analogy. Your eye has a lens that focuses light onto your retina, which then sends electrical signals to your brain. Well, a camera's lens focuses light onto a digital sensor, which creates electrical signals for a computer processor. It's basically the same idea. Which brings us to the absolute most fundamental building block of every single digital image, the pixel. Just think of it as one tiny little dot of light. Every photo, every video you've ever seen on a screen is just millions of these little dots, all arranged in a grid, each one with its own number for its color and brightness. So let's use a super simple example. For you and me, this is a no-brainer. It's the number 9. Our brains get it instantly. But a computer, it doesn't have that kind of intuition. Not yet, anyway. For the computer, that number 9 is, well, it's just this, a big grid of numbers. Each number here represents a single pixel's brightness, on a scale where 0 is pure black and 255 is pure white. All the numbers in between are just the different shades of gray. This grid, this is the computer's reality. Okay, so the computer has the numbers. Now what? It can't just stare at this wall of values and suddenly recognize a 9. The very next step is to start looking for really basic patterns, the first tiny clues that are hidden deep inside all that data. And to do that, it uses something called a filter or a kernel. You can picture it like a tiny digital magnifying glass. It slides over every single part of the image, and it's looking for just one very specific thing, like a horizontal line or maybe a sharp corner. This is a perfect example. This specific grid of numbers is a filter that's designed to do one job and one job only: find horizontal lines. As it passes over the image, those positive numbers in the middle give a really high score when they find a horizontal pattern they like. The negative numbers do the opposite. It's a clever way to make only the right patterns light up. This whole process, it has a name: low-level vision. By using thousands of these different filters, the computer builds up a whole set of maps that highlight all the basic parts of the image, all the edges, the lines, the corners, the simple blobs of color. These are literally the fundamental building blocks of sight for a machine. And why is this so important? Well, think back to that self-driving car. This super simple ability to find edges is the exact first step a car takes to identify the painted lines on a road, separating its lane from the rest of the asphalt. See? It all starts here. So our computer can find lines and edges. That's a great start. But how does it learn that a specific combination of lines and curves makes up a car, or a person, or a stop sign? For that, we need to give it a brain. And in the world of computer vision, that brain is what we call a convolutional neural network, or CNN for short. A CNN is a special kind of deep learning model that's built to take all of those simple low-level clues, the lines, the edges, the corners, and learn how to piece them together into much more complex objects. It sounds complicated, but you can really break it down into 3 stages. First up, the early layers of the network do exactly what we just talked about. They use filters to find basic features. But then, and this is the magic part, the next layers look at those features and learn to combine them into more complex shapes. It learns that a bunch of tiny straight lines can form a curve. Then, pooling layers come in to clean things up, keeping only the most important bits of information. And finally, the last layers of the network look at all this simplified high-level information and make a final decision like, yep, that looks like a 9. And this brain can get pretty darn smart. It can handle different kinds of high-level jobs. For instance, image classification answers the simple question, what is in this image, and gives it one label, like cat. But object detection, that goes a step further. It answers what's in the image and where is it, by actually drawing a little box around every object it finds. So far, everything we've talked about has been with still, static images. But the real world doesn't stand still. So let's bring all this together and put our computer's new vision into motion. Here is a cool secret. At its core, a video is just a trick. It's actually just a long sequence of still images, called frames, that are flashed on the screen one after another really, really fast. And that means every single thing we just discussed, from pixels to filters to CNNs, all that applies to every single frame of a video. But this is where it gets really powerful. By looking at these frames over time, the computer unlocks brand new abilities. It can do object tracking, like following a specific car as it drives down the road from one frame to the next. And it can even do action recognition, not just seeing that there's a person, but understanding that the person is walking or running or even dancing. And there's a great line from our source material that really nails it. It says that motion is what reveals the relationships between objects across both space and time, which gives the computer a much, much richer understanding of what's happening. And just like that, there you have it. We've taken our computer all the way from seeing a single pixel as just a number, to finding edges, to recognizing objects with its own digital brain, and finally to understanding complex actions in a moving video. We've built the fundamentals of sight, one logical step at a time. This technology is moving forward at a truly mind-bending pace. It leaves us with one last, really big question to think about. Now that computers can finally see our world, what on earth will they begin to understand next?